Hi guys, welcome back. Today's video is on what we call inscribed angles. An inscribed angle is an angle whose vertex is on the edge of the circle and whose sides are chords. So you still have to know what a vertex is, you still need to know what chords are. That's going to make this section a lot easier. Okay, and I've drawn three different examples of inscribed angles for you in a circle. They're all still going to fit that definition of an inscribed angle, but notice they go different directions, they're different sizes, so there's a lot of variation in what an inscribed angle would look like inside of a circle. The left picture shows an inscribed angle where angle or vertex A is on the circle, and then your two chords would be segment CA and segment BE. Notice that the inscribed angle creates this arc here from C to B, and what we call that arc is the intercepted arc. Okay, so anytime the angle opens up and creates an arc, that's called the intercepted arc. All right, in the middle picture, I could go ahead and label this maybe D, G, E. So G would be the vertex, and then our chords would be DG and EG. And in this one, notice that the chord EG is also a diameter. And if you remember from the previous sections, chords and diameters are related. Okay, so a chord can be a diameter. And also notice that the intercepted arc here would be arc DE. So when you think about the intercepted arc, think of it as the arc that the angle opens up towards. All right, and then the last one, this would be a very small intersected arc. Maybe we call this angle HFP, and its intercepted arc would be arc HP. Okay, so three different variations, and of course there are tons of different intercepted arcs we can draw in our circles. Now, the most important relationship that you're going to get about inscribed angles is that the inscribed angle is always half of that intercepted arc. So this is why it's so important to be able to identify the arc that goes with the angle. So if I give you an arc, you should just be able to divide it by 2, and that will tell you the degree of the angle. This is different than the central angles we talked about in the last examples, where the central angle is equal to the arc. All right, so central angles are equal, inscribed angles are half. Very important to make sure you have those rules written in your notes. So let's just jump into some examples. So in this first example, it says solve for angle P and then solve for the measure of arc PT. We're going to go ahead and start with angle P, and I've marked this in the picture already. Angle P is an inscribed angle, and if you remember from the last slide, we said the angle is half of the intercepted arc. So what we need to do is identify the arc that goes with angle P. And if you look at your picture, we can just follow this outward, follow the chords, and that's going to get us our intercepted arc of 70 degrees. So to find the measure of angle P, we know that's half of the arc. So I'm just going to plug in what I know. So I know I'm looking for my measure of my angle, and I know that the arc is 70. So right away, half of 70, that's going to get us 35 degrees for angle P, and we're done. So a lot of times those are really short. Okay, then we have to know how to go the other direction. So in the next part of this problem, it says find the measure of arc PT. So in this case, we're looking for this arc here, which means we need to use the inscribed angle that goes with that arc, and that's the 56. So here we know the angle, so we know that the angle is 56, and we know the answer is half of the arc, which is what we're looking for, or PT in this case. So in order to solve for this, I'm going to multiply both sides by 2. And when I do that, the 1/2 and the 2 will cancel, and I'll be left with the arc PT is going to be equal to 56 times 2. And if you do 56 times 2, you get 112 degrees, and then you're done. So we found each arc or angle measure based on that formula from the last slide. And if you have any questions about how to use that, let me know in class. Our next example kind of uses that, but actually goes a little bit further. In this example, they're wanting you to find the measure of arc SV. Now, what you notice here, or you should notice, is that you have two inscribed angles, and those angles create the same intercepted arc. So let me get my highlighter here. So if I follow the the angle T, notice it opens to this arc SV. Okay, and if I do the same thing for my inscribed angle U, okay, I follow its chords out, it also creates the arc SV. So because they create the same arc by intercepting here, that means that angle T and angle U must be congruent. So I'm going to go ahead and write that down. So angle T is congruent to angle U, and the reason is because they intercept the same arc. So this would be a good example to make sure you write down and have that explanation, especially if I ever ask you why are the two angles congruent, you could say because they intercept the same arc. Now we know they're congruent, and that makes solving for x and finding the arc measure much easier, because if they are congruent angles, then all we have to do is set these formulas equal to each other. So to solve this, we're going to have 3x minus 5 equals 2x plus 15. And then I can go ahead and solve for x. And when I solve for x, I get that x is equal to 20. Now, however, you have to pay attention to the question of the problem. They said that here you want to find the arc measure. They don't care about what x is. So we have to actually go further. So what I'm going to do here is plug x back into my problem and find the angle measures. So if I plug this back in here, I'm going to get 3 times 20 minus 5. So that's 60 minus 5, which is 55 degrees. So that's the angle measure. And remember, we said the angle is equal to half of the arc. So if I know my angle is 55 degrees, then to find the arc, I have to double it. So my arc, SV, is going to equal 110 degrees. And we'd be done. So all I did was solve for x, knowing that my angles were congruent, and then I had to go one step further, plugging that x value in, and then doubling the angle to find the intercepted arc. Okay, so please make sure you write those examples down. They're really handy to go back and refer to, and if you have any questions, make sure you ask me in class. We really only have 2 more types of examples to go through. The next one says that if the angle inscribes a diameter of a circle, then that inscribed angle has to be a right angle. And I know the picture might be a little bit blurry here, but I've got this circle, and notice that I've got a diameter drawn in, so FH is a diameter. And then also notice that the angle FGH is an inscribed angle. So it opens up to make a half of a circle, and because this is a half of a circle, that means that this angle has to be a right angle. So this is 180 degrees, which means that angle G equals 90. Okay, so that will work no matter what. If your inscribed angle creates a semicircle or the diameter, then the angle is going to be 90 degrees. And done. And this is handy when you're given triangles in a circle, especially when they have a diameter in this triangle. So in this example, when it says solve for x, because I know that FH is a diameter, that automatically means angle G is a right angle. And now this makes this much easier to solve, because without knowing angle G is 90, we wouldn't be able to solve for x. We don't know that angle F and angle H are congruent, so you don't want to assume that unless they mark them. So the easiest way to solve this now would be to add up all of the angles to equal 180 degrees. So we're going to go ahead and do that. So I'm going to say 4x plus 2 plus angle 90 plus the 9x minus 3 is going to have to total 180 degrees. And now we just go ahead and combine like terms. So we could add 9 and 4, and that's going to get us 13x. And then I could add 2 plus 90, that's 92. Subtract 3, that's going to get you positive 89 equals 180. Then I could go ahead and solve. If I subtract 89 over, I get 13x equals 91. And then if I divide by 13, then I'm going to have my x value, which is 7. So x equals 7. And we're done. And just make sure you always remember, if they are looking for an angle measure, plug your x back in. Always read the full directions to make sure you've answered all parts of the problem. And finally, the last rule of this section, it says if you have a quadrilateral and that is inscribed in a circle, so a couple words you need to know. Quadrilateral, we should know, means a four-sided figure. Okay, and if it says that the shape is inscribed in the circle, that means that every angle of the shape touches the corners of, or touches the edge of the circle. So notice this shape I have here touches every single corner on the edge of the circle. Okay, then what that means is that the opposite angles are supplementary. And hopefully you know this still from last semester, but supplementary means that the angles add to equal 180. So if I put some letters to this, G, K, H, P, then what this means in this problem is, because the shape is inscribed, that the measure of angle G plus the measure of angle H would have to equal 180. So that's G and H here. They're not necessarily congruent, but we know they add up to 180. And then that also means that the measure of angle K plus the measure of angle P would also have to equal 180. So this angle here, P, plus angle K would have to add up to 180. All right, and again, very useful when you're getting some more complex shapes here. We could go ahead and use this example 4 to solve for x and y. So opposite angles would be going together. So I know that 58 plus 2x together will have to be adding up to 180. And now we could go ahead and solve for x. So if I subtract 58 on both sides, that's going to get me 122. And then to solve for x, I'm going to divide by 2. And that's going to get us, it's going to get us 61. So x is 61. And then do the same thing for y. So the y's go together. They are not necessarily congruent, but we know they are supplementary. So 3y plus 4 plus 2y plus 16 equals 180. Combining like terms, I get 5y plus 20 equals 180. Subtract 20, we get 5y equals 160. And then lastly, divide by 5, and we get that y is equal to 32 degrees. And again, if they ask for the angle measures, make sure you plug those answers back into your picture and make sure you find the correct degree measures. But in this case, they just want x and y, so we'd be finished.